Happy Monday, everyone. So today we are talking about forces, yay! So it says it's 20% of your exam. Again, though, those numbers are being shifted because we're getting rid of simple harmonic motion and gravitation. So today we're just going to quickly review this PowerPoint. It's attached to the classroom post in case you'd like to follow along. And remember, these videos cut off after 5 minutes, so if I'm in the middle of a sentence, that's why. So first things first, forces, just an interaction between an object and an agent. Push or a pull of some sort, okay? And every single force, except for gravity, okay, Fe and Fb, remember we're not doing Fe and Fb, that's just from last year. The agent must be physically touching the object. Now, okay, my laptop, I'm not touching it. I cannot be putting a force on it because I am not physically touching it, okay? And forces are measured in newtons, okay? So 1 Newton is 1 kg m over s squared, okay? And that is a picture of Isaac Newton and all of, so that's what he looks like. Okay, and as you notice, our vector symbol is right here up here in the corner, meaning forces are vectors. The direction is super, super important. Okay, now Newton's first law of motion. It looks like this video just decided not to work, okay? But an object moving at constant velocity will continue to move at that constant velocity unless acted upon by an outside force. Let's try it anyway. Nope. Okay, well, it was a fun video, but remember the demo I did with the pop bottle, the ring, something on top of the ring, you remove the ring, it falls straight through. Okay, that's because there's no force acting on the object, it'll just fall straight down because of gravity. Okay, now, Newton's second law. Oh, just kidding. Inertia. Okay, inertia is the tendency of an object to resist acceleration. Now, this is closely related to moment of inertia, which is the tendency of the object to resist angular acceleration. So inertia and moment of inertia are related. Inertia is linear, moment of inertia is angular. Okay, now the second law, sum of the forces equals ma, so may the mass times acceleration be with you. Okay, so acceleration is directly proportional to the sum of the forces acting on it and inversely proportional to its mass. Okay, we did a law with Newton's second law, or a lab with Newton's second law, so go ahead and check that out. Okay, third law. Okay, this picture says Sir Isaac Newton, mathematical musical. So for every action, there's an equal but opposite reaction. So Earth is pulling me down the exact same amount that I am pulling up on the Earth. Okay, so if I have two boxes, okay, one is being pushed, okay, this one is pushing on this one is pushing back on this one. So these forces go on opposite free body diagrams. They do not go on the same free body diagram. Speaking of free body diagrams, we draw a dot at the center of mass, okay, and then we just draw our vectors, okay, in the correct direction. Now, a couple things about the AP test. Do not draw components. So if something's at an angle, don't draw the X and Y component. It will say, don't draw components, don't do it, okay, unless it's specifically asked to do it. If it asks, obviously do it, otherwise do not do it. Another thing, the forces act where the forces are. So if it's acting at the center of mass, you draw it at the dot. If it's rotating and it's acting to torque, okay, on an angle, draw it there. Okay, so make sure you're drawing it in the correct place. One more thing, the vectors have to be the correct length. So if, gravity is the same for both objects, the vector has to be the same length. If it's different amount of gravity, we need different vectors. Okay, so make sure you're paying attention to those lengths. Okay. Little thing about normal and gravity, they do not equal each other, okay, unless there is no vertical acceleration and they are the only two vertical forces, okay? So that's not always true. You cannot assume that Fn equals Fg, okay? So just kind of keep that in the back of your mind. Do not just say Fn equals mg. That's not always true. So think about in an elevator, when it's going upwards, you feel heavier. You're not actually heavier, but your apparent weight is changing because your normal force is changing.